Good morning, friends. Today we have Intel 8086 architecture for discussion. Let us start discussion with features of 8086. 8086 is have 16-bit ALU and 16-bit registers so that it have ability to process 16-bit data. It is provided with 16-bit data line, 16-bit data bus, that is, we can transmit or receive 16-bit as well as 8-bit data from peripheral to microprocessor or microprocessor to peripheral. It also have 20-bit of address line, which is extended one, which supports 2 raised to 20 means 1 megabyte of user memory. So user can store any kind of data within this particular memory. It also supports multiprocessing capabilities, that is, this processor can be incorporated with, can be used with different co-processors like 8087 or 8089. Again, it can be used with 5 volts of supply. It comes in different versions like 8086, 80862, 80861, which uses with different clock frequencies of 5 MHz, 8 MHz and 10 MHz. It comes in 40-pin configuration with HMOS technology. It has address and data lines multiplexed together to reduce the pin counts of the 8086. It supports pipelining, that is, multiprocessing environment is also possible within this microprocessor. Now here we have internal architecture of 8086. So as shown in figure, we can discuss or we can have that this architecture is divided into two different parts, that is bus interface unit. Bus interface unit is completely responsible for communication within microprocessor or communication with microprocessor to peripheral or peripheral to microprocessor. It have different segmentation registers, it have execution, it have instruction queue, it have instruction pointer. Similarly, we have execution unit, that is EU, which is responsible for execution of program that is provided by the user to the microprocessor. It contains general purpose registers, it contains flags, it contains ALU, that is arithmetic and logical unit. So here we have details of internal architecture of 8086. So first, segmentation. In 8086, the total memory of 1 megabyte is segmented into 4 different segments as extra segment, stack segment, code segment and data segment. Data segment is responsible for storing or locating the operand data which is required by the microprocessor during execution. Code segment is responsible for indicating or storing the codes of the program. Stack segment holds the information of stack, and extra segment is again like data segment which holds the data. Queue queue have 6 different registers. Each register is of 16-bit wide. This particular device is also known as prefetching register. So instructions which are going to fetch by microprocessors are going to store in this particular register. Now the nature of queue is last in first out, that is, last entered instruction within queue is getting executed first. Here we have instruction pointer. Instruction pointer is nothing but program counter of 8086, which going to hold the address of the next instruction to be executed by the microprocessor. It also gets auto incremented when execution of program proceeds further. Here the 20-bit address of the program code also can be calculated with the help of instruction pointer and code segment register contents of code segment register. We have general purpose registers. So 8 general purpose registers are used in 8086: accumulator, BX register, CX register, DX register, stack pointer, base pointer, source index and destination index. So first 4 registers are 16-bit registers. Each register is divided into two different parts, that is 8-bit of each, that is AX register or accumulator is divided into AH and AL. Similarly, BX register is divided into BH and BL. CX register is also divided into CH and CL. DX register is divided into DH and DL. Each of these registers are 8-bit wide and combinedly creates a 16-bit register. Stack pointer, base pointer and source index, destination index are again 16-bit registers used for different purposes of executions of 8086 programs. 8086 flag register is 16-bit wide. It have 16 different flag bits, but among those 16 different flag bits, only 9 flags are going to be used. Remaining flags are left for discussion, or remaining flags are left for further research in microprocessors by Intel. Here, out of 9 different flags, 6 flags are conditional flags. These are carry flag, auxiliary carry flag, parity flag, zero, sign, and overflow flag. So these are nothing but flags which indicates the output status of the microprocessor. Similarly, we have 3 different control flags as trap flag, interrupt flag, and direction flag. So with the help of these flags, we can change the operation of the microprocessor. Then we have ALU, that is arithmetic and logical unit. So this is nothing but a basic unit which is completely responsible for operations of the microprocessor. We can say this is nothing but the brain of the microprocessor. Here all data, all programs are getting processed. It can perform logical as well as arithmetic operations as given by the user. Similarly, it can be incorporated with NDP 8087 to perform floating point operation. So in this fashion, we can explain the architecture of 8086 microprocessor. Thank you.